in this section here, we're going to be looking at finding the trig ratio given a point that the terminal arm of the angle passes through. So what I want to try and do is I want to move away from us using SOHCAHTOA and try to move towards using x, y, which is any point that it passes through, and r instead of the hypotenuse. Now, the reason I want to do this is twofold. First of all, when we get into 30-1, this is the notation that we use. The reason that we use this notation is because it's based on a unit circle. So imagine if I were to draw a unit circle around here, or if I were to draw some sort of a circle all the way around, and there are several points that this circle passes through. If I were to connect the point to the origin, I would get a radius. So our hypotenuse of the triangle is really the radius of a circle. We're just not drawing the circle yet. So if I take any point that it passes through, draw a perpendicular line segment down, I can see that that triangle has a length along the bottom of x, a vertical height of y, and we're going to call this hypotenuse r. So I just want to challenge you to try and get used to this notation. Again, if you need to use SOHCAHTOA, that's okay. This is kind of a preview to what we're going to do in 30-1. Now, something that I want you to know as for this circle and for any time we use trig ratios in any of the quadrants, the hypotenuse, or in this case, radius, will always be positive. So x and y can be positive or negative, but the radius will always be positive. So if I were to look at this circle and this triangle that I've drawn here using SOHCAHTOA, you can see that we have our new notation. So for example, sine. Sine is opposite over hypotenuse. So you can see opposite, which is y, over hypotenuse r. So the sine ratio of any point on in our coordinate system can be found by taking the y value over the radius. Okay. If I then look at cosine, so cosine we know is adjacent over hypotenuse. So adjacent would be the x value, hypotenuse would be my r value. So the cosine of any angle passing through a point xy can be written as x over r. And then lastly, we have tangent. So tangent is opposite over adjacent. So opposite y over adjacent x. So this is how we can find the tangent of any angle given a point that the terminal arm passes through. So I'm going to use this notation moving forward just to kind of get us prepared for the next level. And also when we get to quadrantal angles, it will really help. Okay, so now what we're going to do is find the trig ratio given a point that it passes through on the terminal arm. So let's say I have a point in my coordinate grid and I say that a point or an angle passes through this point. Here's the steps that we're going to do to find out what that angle is. The very first thing is we're going to plot the point, whatever quadrant it's in, and connect it to the origin. So the origin, that point 0, 0. So when I connect the dots there, that is actually going to form my hypotenuse or the radius. From that point, we're going to draw a perpendicular line from that point to the x-axis. So this is how we are getting our triangle. It's going to look like that. Okay, where this is the point that it passes through, this is the origin, and then we can label our points. So along here x, along here y, and along here r for radius. So we're going to label all of our legs of the triangle, paying attention to the quadrant it's in. So x and y might be positive or negative. R is always positive though. And then we're going to use our Pythagorean theorem to find our hypotenuse, remembering that the hypotenuse will always be positive. And then once we've done that, we can find the exact trig ratio in that quadrant for that angle. So let's try an example here. So I have the point 3,4 that lies on a terminal arm of theta in standard position. I want to determine the exact ratios for sine, cosine, tangent, and then I want to find my angle. So let's first of all plot our point 3 and 4 connected to the origin. Okay, so there's my point. I always drop down a perpendicular line to the x-axis, and now I'm ready to label. So along the x-axis, it measures 3. Along the y-axis, the height, it measures 4. So I'm going to use Pythagorean theorem to find my hypotenuse. So I have a squared plus b squared equals c squared, or actually I'll label that as r squared. So I have 9 plus 16 equals r squared. So r squared is 25. The square root of r is 5. So I know that my radius, or my hypotenuse, is 5. So this is also a Pythagorean triple. Okay, so Pythagorean triplet of 3, 4, and 5. So anytime you see side lengths of 3 and 4, I know the hypotenuse or the radius is going to be 5 right away because it is a Pythagorean triplet. So you can memorize that one or use Pythagorean theorem. So to figure out sine, sine is y over r. So y over r. Cosine is x over r. And tangent is y over x. So there are all of my ratios. Now I want to find the measure of my angle. So to figure out the angle in quadrant 1, all the sides are known, so any trig ratio can be used. Okay, so what I can do is, ignoring the signs, well in this case they're positive, so I don't have to worry about that. I can do sine inverse, cos inverse, or tan inverse, whichever one you want, and you can see you get the same angle measurement. So I know that my angle is, to the nearest degree, 53 degrees. Okay, let's try one in quadrant 2 now. So now I have a point -512 lying on the terminal arm of theta, and I want to determine the exact values for sine, cosine, tangent. So again, first thing that I'm going to do is plot my point, -512, and then draw down a perpendicular line to the x-axis. So there's my little triangle. So let's label what we already have. So we already know along x is -5, along y is 12, so I'll label those. Now notice I've done that with the sign. So it's not a 5, it's a -5. So I can use Pythagorean theorem to find my hypotenuse. So I'll do a squared, notice how I'm putting it in brackets, plus b squared equals c squared. So 25 plus 144 equals, let's actually call that r squared instead of c, because that's the radius that we're solving for. So add those together and I get 169 equals r squared. Taking the square root, r is equal to 13. So I can label that as well. Hypotenuse is always positive. This is another Pythagorean triplet. So 5, 12, and 13. So if you remember that, you don't have to use Pythagorean theorem, but of course you always can if you want to. Okay, let's look at sine, cosine, and tangent. So paying attention to the signs. So sine is y over r. Y over r. Cosine is x over r. Tangent is y over x. And I don't like my negative in the denominator, so always put it in the numerator. It's just good convention. I'm going to write it as -12 over 5. So those are all my angles, or all my ratios. Now I'm going to find the angle theta, the measure of theta. So looking at my triangle here, I am going to ignore the signs because the signs, all they do is place it in the quadrant. But to find the angle, we want the smallest reference angle. So ignoring all the signs, I'm going to punch into my calculator all of the different ratios. So sine inverse, cos inverse, tan inverse. I'm using inverse because I want the angle. You do not need to do all three. I'm showing you all three to show you that it doesn't matter which one you choose. So whichever ratio that you choose, my reference angle to the nearest degree is 67. So my angle is a quadrant 2 angle with a reference angle of 67. So now I just have to figure out what my actual angle is. So since it's in quadrant 2, it hasn't reached 180 yet, so it's 180 minus the reference angle. 180 minus 67 means that my angle is 113 degrees. Okay, last example that I'll do is a quadrant 3 angle. So suppose that theta is an angle in standard position with a terminal arm in quadrant 3 and tangent ratio of 1 over 5. Determine the exact value of sine and cosine, and then again find the measure of theta. So we know that tangent is equal to 1 over 5. So I'm just going to draw my triangle, and I know that the tan ratio, which is y over x, is 1 over 5. So I can just label those sides as 1 over 5. Now this is not a Pythagorean triplet, so I need to use my Pythagorean theorem to find out the measure of my radius. So I'm going to do x squared plus y squared equals 2r squared. A squared plus b squared equals c squared, whichever way you prefer. So 1 plus 25 equals r squared. So r squared equals 26. Therefore, I know that r would equal to the square root of 26. Now, if I can reduce that, I would. But 26 only has factors of 2 and 13, so there's no perfect square factors. So I'll leave it like that. Again, the radius is always positive. So now that I know my side lengths, I have to pay attention to the quadrant that I'm in. I'm in quadrant 3. So even though the tan ratio is 1/5, the reason it's 1/5 is because tan is positive in this quadrant. But in quadrant 3, x and y are both negative. So a negative over a negative is a positive. So that's why tan is positive. So once you've figured out the sides, you need to label them for the quadrant that you're in. Okay, so let's do sine and cosine. So sine is the ratio y over x. So -1/√26. Now, we don't leave a root in the denominator, so I need to rationalize by multiplying top and bottom by the root of 26. So if I multiply top and bottom by root 26, I'll get my final answer. So that's just going to be -√26 all over 26. Okay, cosine is x over r. So x over r. And again, I need to rationalize the denominator by multiplying top and bottom by root 26. If I do it to the top and the bottom, it's fair because I haven't changed the question. So this will be -5√26 all over 26. So I've got sine and I have cosine. Now I need to find the angle measurement. So going over here in quadrant number 3, ignore the signs and you're going to find one of the trig ratios, any one that you want. I'm going to show you all 3 just to show you they're all the same. You would just choose one of them. And if it was me, I'd probably use tan inverse because those are nice numbers, they're both positive, and it's easier to enter in. But you can use whatever you want, ignoring the signs. So because this is a quadrant 3 angle, I'm using a quadrant 3 angle with a reference angle of 11 degrees. So in quadrant number 3, it's greater than 180. So it's past 180. So I'm going to do 180 plus my reference angle to get my final answer that theta is equal to 191 degrees. Okay, in the last little bit here, I just want to talk to you about quadrantal angles. Quadrantal angles are any angles where the terminal arm is the x or the y axis. So in just one turn around the coordinate grid, I have 4. So I start at 0. Here it would be 90 degrees because quadrants are split into 4 sections, each section being 90 degrees. 270. And then I can go back to where I started is 360. So each one of these are quadrantal angles. So I know that we can punch these into our calculator and figure out what the sine, cosine, or tangent is, but I want to show you why they have those measurements. So let's do a quadrantal angle of 90 degrees. So we just looked at how to find the trig ratios of any angle passing through a point xy. So what I'm going to do is I'm going to take this point of xy and I'm going to slide it up to 90 degrees, which is the y-axis. Now by sliding it over here to the y-axis, my point xy becomes the point 0 and y. I don't have a triangle anymore. I just have a line segment. But I'm going to use everything I know about my trig ratios to calculate, without using a calculator, the sine, cosine, and tangent of 90 degrees. So when I slide that over there, you can see here that x becomes 0, y stays as y, but let's talk about what the radius is. So if I slide this line segment over from here to here, the radius has to have the measure of whatever the height of this is, remembering that the radius is always positive. So I know that the radius also has a length of y. So what I do is I figure out when I have a 90-degree angle, x is 0, y is y, and the radius, since I've collapsed the triangle, has the same measurement as y. So I'm going to use what I know about sine, cosine, and tangent to figure out the ratios for this 90 degree. So I know sine of any angle in general is y over r. Well, let's look at 90 degrees. My y value is still y. My r value is y. And y over y is 1. So that tells me sine of 90 degrees is 1. Cosine of 90. Well, cosine of any angle is the ratio x over r. Well, x for 90 degrees is 0 over r, which is just y. 0 divided by y, 0. So I now know that cosine of 90 is 0. Let's look at tan. Tan is the ratio of y over x. So y is still y. X is 0. So y over 0. Well, one of the rules in math is you cannot divide by 0. So that is undefined. It's not allowed. So that tells me that the tangent of 90 degrees is undefined. So now that you see why it works the way it does, let's check to see on the calculator if we're right. So on the calculator, you can see sine of 90 is 1. Yep. Cosine of 90 is 0. And tan of 90 is an error. It's undefined. But now you know why that actually works the way that it does. Let's try one more, and there's 2 more for you guys to do in your homework. So I want to find the exact values of the quadrantal angle 180 degrees. So I'm taking this point xy, which is any point, and I'm going to slide it over till it's at 180 degrees right there. Now 180 degrees lies along the negative x-axis. So this point xy becomes a negative x-axis. So you can see that x becomes negative x, y becomes 0, and then remember radius, since I've collapsed the triangle, is just the length of the line segment. Now the length of this line segment is negative x, but the length of it, because length can't be negative, is just x. So I'm going x units to the left, because remember the radius always has to be positive. So what that tells me here again is that for 180 degrees, x becomes negative x, y becomes 0, the radius is x because the radius is always positive. So let's figure out the sine, cosine, and tangent of 180 degrees. So sine of 180, we know sine is the ratio of y over r. Well, y is now 0, and r is x. 0 over x is just 0. So that tells me sine of 180 is 0. Cosine of 180, well, that's x over r, the ratio of x over r. X we see as negative x, r is positive x. Negative x divided by x is negative 1. So that tells me that cos of 180 is negative 1. Now tangent, that's the ratio of y over x. Y is 0 over x, which is negative x. 0 over negative x is 0. So that tells me tan of 180 is 0. So let's check on the calculator to see if we're right. Sine of 180, 0. Cos of 180, negative 1. Tan of 180, 0. So you can see on the calculator you're right, but now you know why those values are true. So I hope you guys enjoyed this lesson. You guys can say that I really do like angles to a degree. You guys can go ahead and finish off the second part of the practice questions, which is numbers 4 to 9. And then you can see I have some textbook questions there for you as well. So I hope this video helped, and I look forward to seeing you for the next one.